In this video, we are going to look at a form of a quadratic equation called vertex form. And I'll write an example of it right here. Y is equal to 2 times x plus 3 quantities squared. So I'm squaring everything inside the parentheses here, and then subtract 2. So in order to see how we can find the vertex from this form, let's see if we can reason our way through what's going on in this equation. So one thing that we might notice is that this part of the equation here is always going to be greater than or equal to 0. Now, the reason that this is always going to be greater than or equal to 0 is because no matter what I substitute for x, I'm always going to be squaring what's inside the parentheses here. And so the lowest number that I can get out of this is 0. Even if I have a very negative number for x, if I multiply a negative by a negative, it's going to give me a positive. And obviously, if I substitute in a positive value for x, then I'm going to have a positive times a positive, which is going to be positive, and then I'm going to multiply it by this positive 2 over here. So the lowest this number can be is 0. And then we're going to be subtracting 2 from this number. So we have a lower bound on this graph. We have a low point that we cannot go below. And so that tells us that the graph of this function is going to look like this. It's going to be a quadratic that opens up, and our vertex will be the lowest point on the graph. So let's look at what will this lowest point be. Let's find out what the y value of this lowest point is. And so in order to figure that out, let's imagine what's the smallest we can make this part of our equation. What's the smallest we can make it? Well, we actually know what the smallest point that we can make it is because we know that it's going to be greater than or equal to 0. And if it can be equal to 0, then that will be the lowest point on our graph, because we'll have 0 for this part, and then we'll subtract 2. Now, how can we make this 0? Well, the only way that we can make this 0 is to find out some way that we can make the part inside the parentheses, that we can make that equal to 0. So how can we make x plus 3 equal to 0? So let's see, and let me organize here. So we're finding the vertex, and in order to find the vertex, we want to find out how can we make this equal to 0. So if I have the parts inside the parentheses here, I want to find out what value for x is going to make that 0. Well, I can just use algebra. I subtract 3 from both sides, and that gives me x is equal to negative 3. And so if I substitute in negative 3 for x, then I'm going to have negative 3 plus 3. So this is going to be 0. And then I'm going to square it. And so I'm going to have 0 squared. And then I'll multiply that by 2. So it's going to be 2 times 0 squared, which is 2 times 0. And so all of this is going to go to 0. And then I'm going to have subtract 2. So let me write out what I mean by that. I will do it over here to the right. Let me continue this line over here. So if we have y is equal to 2 times, and then I'm going to substitute in this negative 3 right here. Negative 3 plus 3. And then I'm going to square that, and then I'll subtract 2. So this is going to tell us when we substitute in negative 3 for x, what's the y value that we get out of it. So I'll just continue to simplify here. Negative 3 plus 3 is 0. So I have 2 times 0 squared, subtract 2. And this part, we know, is going to, I'll write at the intermediate step, 2 times 0, because 0 squared is just 0, subtract 2. This part's going to go to 0, so we're just going to have y is equal to negative 2. 2 times 0 is 0, subtract 2. We're just left with negative 2. So the y value of our vertex right here is negative 2. And we already know the x value for our vertex. We found it up here. This is the point on the x-axis where we reach our lowest point on the graph. So we have the coordinates for our vertex. We can write those as an ordered pair. Negative 3, subtract 2. So these are the coordinates of our vertex. So let's go ahead and plot the vertex over here in yellow. Let's see, so we're going to go to -3 on the x-axis, which will be right there, and then -2 on the y-axis, which will be right there. So this is our vertex. The next thing that we need to find are our x-intercepts. So I'll write that right here, our x-intercepts. Remember, those are just the points on the graph where the graph intersects the x-axis. And so in order to find out what the x-intercepts are, we just want to find out for what values of x is y going to be equal to 0. And so let's write that out as an equation. Y is equal to 2 times, or sorry, 0. 0 is equal to 2 times x plus 3 squared subtract 2. So for what values of 0, or sorry, for what values of x is y going to be equal to 0? So I can simplify this by adding 2 to both sides. And that gives me 2 is equal to 2 times x plus 3 squared. And then I want to divide both sides by 2. So I'm left with just the parentheses squared on this side. So I'm going to continue over here to the right. That's going to give me 1 is equal to x plus 3 squared. 1 is equal to x plus 3 squared. And now when we're in this situation, we can use the square root operator in order to undo our squaring operation on this side. So I'm going to take the square root of both sides. And now right here, we're actually going to split and finish by solving the two separate equations that are the outgrowth of this. Let me explain what I mean by that. When we take the square root of 1, we're asking what number, when we multiply it by itself, is going to give us 1. Well, there's actually 2 numbers that when we multiply them by themselves, they give us 1. 1 times 1 gives us 1, but so does -1. If we multiply -1 by itself, that gives us 1 also. And so we actually have 2 different options here. We have the +1 option and the -1 option. And so we have 1 is equal to x plus 3, because we're taking the square root of something that's squared, so we're just left with what's inside the parentheses here, x plus 3. And then we have -1 is equal to x plus 3, and then we can just finish these with algebra here. We subtract 3 from both sides, and that gives us -2 is equal to x. So that's going to be one of our x-intercepts. So let me write that a little more clearly. -2 is equal to x, and then similarly we subtract 3 from both sides, and that's going to give us -4 is equal to x. Sorry, writing a little bit small and a little bit smushed down here in the corner, but these are my 2 x-intercepts. I have one at -2 and one at -4. So I'll plot those over here on my x-axis. And one thing that you should notice here, or that we can notice, is that these x-intercepts are equidistant from from the x-intercept of our vertex. Remember, the x, or not the x-intercept, but the x-value of our vertex. Our vertex was at the x-value -3, and each of our intercepts is 1 step away, or a distance of 1 unit away from the x-value of our vertex. So we found our vertex, we found our x-intercepts. The last thing that we want to find is our y-intercept, and so I'll do that over here, our y-intercept. And in order to find our y-intercept, we want to find out when x is equal to 0, then what is our y value? That's the same way that we would find our y-intercept if we were graphing a linear function. And so I'm going to rewrite the equation here, and I'm just going to replace or substitute a 0 in for x, and then we'll find out what y is when x is 0. So what's the y value when we're at this point on our graph? So that's going to be y is equal to 2 times 0 plus 3 squared, subtract 2. And then I can just simplify this here. So I have y is equal to, this 0 plus 3 is 3. So I'm going to have 2 times 3 squared, subtract 2. This is a 3. And then 3 squared is 9. So I'm going to have y is equal to 2 times 9, subtract 2. 2 times 9 is 18. So I have 18 subtract 2, and that leaves us with y is equal to 16. And so our y-intercept is going to be where the y value is 16, or at the coordinates 0, 16. That's the ordered pair for where our y-intercept is. And so I can plot that. Let's see, this will be off my graph. It'll be somewhere up there. And I'll just add in a little arrow there saying that this is the point 0, 16. All right, so we have our vertex, we have our x-intercepts, we have our y-intercept estimated up here. So that's the information that we need in order to graph this quadratic function. And so I'm going to actually use a little tool to make sure that I'm mirroring across my axis of symmetry. This is my reflection tool. And so I'll just see how well I can draw this quadratic function. Oh, it's a little wavy. There we go. That's not so bad. We have our arrows up here. And that is the graph of this quadratic function. Now, how do we use this vertex form in order to find what does this particular form of the equation tell us about this function? Well, vertex form is y is equal to a times x subtract h squared plus k. And our vertex is going to be at the point h, k. That's how we use vertex form. It tells us the vertex in these two, and whatever numbers that we substitute for h and k here. And so if we look at this, we actually have x plus 3, which is the same as x subtract negative 3. And so looking at this, we would know that our vertex is the x value of our vertex is at negative 3, which indeed it is. And then we also know that the y value of our vertex is at negative 2, which indeed it is. So again, this is vertex form. You look at the value for h and k, and that tells you where your vertex is. So let's look at this with another problem. So I'm going to hide this screen and pull up another one. And let me get rid of my symmetry tool here. Okay, let's. I'll just rewrite the vertex form over here. So that's y is equal to a times x subtract h squared plus k. And so remember, h and k are going to define the point of our vertex. So vertex at h, comma k. Okay, so let me write up another quadratic in vertex form here. So we have y is equal to negative 4 x times x plus 1 squared plus 4. And we have a similar situation as to our last equation, where we have x plus a number here instead of the form that it describes, where it's x subtract a number. So I'm just going to rewrite this so that I have subtraction in here. So that's going to be y is equal to negative 4 times x, and then I'm going to write this in teal just to make that clear. X subtract -1 squared plus 4. So these are equivalent equations. Remember that subtracting a negative is the same thing as adding. So I've just replaced my adding 1 with subtracting -1 here, just to make it so that it looks more like the form that we're going for. Okay, so this tells us that our vertex is at the point, let's see, our x value is going to be -1. And our y value is going to be +4. So just like that, we already know our vertex, and I'll write it here in teal. So I'm going to go to -1 on the x-axis and up to 4. That's going to be right on top of my 4 right there. Okay, so we have our vertex. Let's find our x-intercepts. X-intercepts. Okay, so for our x-intercepts, remember, we just want to find out what values for x are going to make y equal to 0. So the x-axis is where y is equal to 0. So we're just going to rewrite our equation here, and we're going to substitute in 0 for y, so that we can figure out what values for x are going to make y equal to 0. So we have 0 is equal to -4 times x, and I'll just use the original form up here, x plus 1 squared plus 4. And I want to solve this for x. So I can subtract 4 from both sides. So I have -4 is equal to -4 times x plus 1 squared. And then I can divide the left-hand side by -4. -4 divided by -4 is 1. And then -4 times x plus 1 squared divided by -4, these are going to go to 1. And so that's going to just leave me with x plus 1 squared. And now I can, just like I did before, I can take the square root of both sides here. And remember that there are 2 roots for 1. We have 1 and -1. So that's where I'll split this out into +1 and -1. So one of my equations I'm going to set equal to 1, where we have 1 is equal to x plus 1. And then my other equation is going to be -1 is equal to x plus 1. And I'll solve the left-hand side, or the left problem first. So if I subtract 1 from both sides, that's going to give me 0 is equal to x. And then on the right-hand side, subtract 1, that gives me x is equal to -2. So these are my x-intercepts. I have an x-intercept at 0 and an x-intercept at -2. So I'll mark those here, 1 at 0, 1 at -2, and notice that these are equidistant from the x value of our vertex, or equidistant from our line of symmetry, which I can draw out right here. It's going to be right here. This is going to be our axis of symmetry. And so now that I have my x-intercepts, I have my vertex, I also have my y-intercept. I know my y-intercept already, but let me just show you so we can review how to find it algebraically. So remember, for my y-intercept, I'm just looking for the point at which x is equal to 0. So I can rewrite the equation here, and I'll just substitute in a 0 for x. Y is equal to -4 times 0 plus 1 squared plus 4. And I want to, all I need to do is simplify this to find out what y is equal to. So we have y is equal to 0 plus 1 is equal to 1. And so I have -4 times 1 squared plus 4. And 1 squared is equal to 1 times -4 is just going to be -4 plus 4. And so our y-intercept is going to be at -4 plus 4 is 0. So y is equal to 0. That's where our y-intercept is going to be. And so I already have that on the graph here, but I'll just add a second little yellow dot there. And we have all the information we need to graph this quadratic. So I will graph it in green. Let's see if I can do it freehand this time. So do the left-hand side down here, something like that. And then the right-hand side down through my x and y intercept. Ooh, that's a little crooked. Let's try that one more time. Down like this. Oh, not bad. Not bad. Okay, so now we have the graph of this quadratic. Notice that it mirrors across this axis of symmetry in the middle here. Quick review. This is the form. This is the vertex form. And it is arranged in such a way that it makes it easier for us to pick out the vertex, but we still have to find the x-intercepts and the y-intercept in order to graph the function.